Hello, and welcome to the Science for Sleepy. Tonight, let's take a gentle walk through space and thought, tracing the soft silver threads of a question that has quietly puzzled minds for centuries. Why does light have a speed limit? Outside, the stars are blinking slowly, like tired eyes. Our little laboratory sits tucked in the folds of a silent hill, its windows glowing warm gold against the indigo sky. Inside, it smells faintly of old paper, lavender oil, and something electrical. Like curiosity humming through copper wires, a cat naps by the radiator, a kettle whispers steam, and somewhere in this safe, quiet place, we begin. If you're enjoying this quiet journey through curiosity and time, consider subscribing. There's always more to explore gently. We'd love to know your location and time zone in the comments. Tonight, we find ourselves holding a lantern. It's old, glass and brass, and when we click it on, the light that spills out seems to shimmer with a question. Where does it go? And why does it go so fast yet never faster? You step outside with the lantern, and the air is cool on your skin. Around you, the night seems vast but familiar. The trees breathe slowly, and the moon is a pale coin balanced on the edge of the sky. You hold the lantern still, and the light casts a slow-moving cone through the darkness. The beam stretches forward, reaching toward the meadow like a thought searching for the right word. But unlike a thrown stone or a running deer, the light doesn't speed up, doesn't hesitate. It travels at one speed, precise, unwavering, absolute. Not because something's in the way, not because the night is heavy, but because that is the fastest anything can go, and always has been. Isn't that strange? In the quiet that follows, we consider a whisper of a possibility, that the universe isn't just permitting this speed, it is enforcing it. You sit on the old bench beside the garden and gaze at the stars overhead. Those tiny points of light are, in truth, ancient. Their messages took years, sometimes centuries, sometimes millennia, to reach you. And yet, no matter how far they've travelled, they all obeyed the same silent rule. No faster than 299,792,458 meters per second. That number is not round, not poetic, but it is deeply meaningful, as though the universe stitched it into its very code. In a dream, imagine you could float up there, beside the stars, and hold time in your hand like a droplet. Would the light rush past you, desperate to reach the end? Or would it simply move, calm, constant, not needing to rush at all? Light is not impatient. Its speed is not a sprint. It is not trying to break through. It is the speed of space itself. It is woven into the empty distances between everything. It is what lets us see the world, and what defines the structure of reality itself. And yet, it raises a quiet question in our shared mind. Why that speed? Why not faster? Why not slower? In the hush of the lab, we place the lantern gently back on the table and listen to its filament hum as it cools. A single beam of light once raced into the darkness, but it never changed pace. Not because it couldn't, because it doesn't need to. So begins our journey. We won't chase light, we'll walk beside it. The lantern has gone out now. Its glow still lingers in your vision, like a memory. You blink once, twice, and in the after image you see it. A beam of light, frozen in the air, still, silent, as though you could walk around it, touch its edge, see what it's made of. Let's stay with that image a moment longer. The light is not a ribbon or a rope, not a thread tied to anything. It's more like a pulse, a quiver in the dark, a ripple, a flicker, a wave without water. But what is it? Light, we're told, is both a wave and a particle, a photon specifically. It travels without mass, yet it carries energy. It vibrates, yet moves in a straight line. It is in many ways a paradox made visible. You look closer. The frozen beam reveals a gentle shimmer, as if made of tiny threads moving up and down, not side to side, not forward, but through themselves. This shimmering wave doesn't push against anything. It doesn't need a medium, like sound needs air or ripples need water. It moves in a way nothing else does, and yet it always moves, never still, never pausing. If it did, if you could somehow stop a photon and hold it, it would cease to be light. It would become something else entirely, maybe nothing at all. That's part of its mystery. Photons don't rest. In fact, they don't even experience time. For a photon, born in the heart of a star and extinguished in your eye, the journey takes no time at all. No seconds, no ages. It is always now. The light simply is, and its motion is not about effort, but identity. It moves not through space, but as space. Not in time, but with time. We wonder, gently, curiously, what it would mean to be made entirely of motion. You reach out toward the frozen beam. The moment stretches, soft and infinite. And then, just like that, the image fades. The beam resumes its journey. It slips through the air, untouchable and unseen, unless it strikes something and tells the world, "I was here." You follow it now, not with your feet, but with thought. The photon races forward, but not like a bullet, not like a car. It does not accelerate. It does not build momentum. It simply begins. And the moment it begins, it is already travelling at the only speed it ever can. This is unlike anything else in the universe. Everything else, you, me, stars, stones, must be pushed to move. We crawl from stillness into speed, but not light, never light. There's no winding up, no start button. It always moves at the speed of light. Why? Let's lie back for a moment. The grass is cool, and the stars above have gathered closer. They lean in, listening. What if the speed of light is not something light chooses, but something space itself requires? After all, light is made of electric and magnetic fields, invisible things that dance around each other. They create each other, sustain each other, and together form what we call electromagnetic radiation. These fields can only exist in motion. They only sustain each other if they are moving, and they only move at one speed. You could imagine a photon like a duet, electric field on one arm, magnetic field on the other, spinning forever in perfect balance, but only if they never slow down. Slow down, and the song stops. Slow down, and they cease to be light. That's why light doesn't move at this speed because it wants to. It moves this way because it must, or it disappears. The number itself, that strange exact 299,792,458 meters per second, emerges not from some ancient law etched into stone, but from the properties of those very fields, their strength, their relationship, their interaction. It is not just a limit, it is the only way they can exist. You close your eyes, and the thought settles softly. Light speed is not a barrier, it is a balance. The next time you see a sunbeam drifting through your window, remember that its very presence means it is being sustained constantly by a perfect relationship, by two invisible forces entwined in eternal motion. The moment they stop, they vanish. And maybe that's a little like us too. The stars have faded just slightly now, but not because the sky has changed. You're drifting, not asleep, not quite, but gliding inward. The questions float more slowly now, like leaves in a still pond, and so we ask gently, if light must move at that speed, what exactly does it move through? We often imagine things travelling across something, boats on water, birds through air, even thoughts across a brain's soft pathways. But light, strange, silent light, moves through space itself, not through objects or particles, but through the invisible architecture of emptiness. Let's walk together through that space now. It stretches in every direction, silent, endless, dark as velvet, but not empty, never truly empty. Even space that holds no stars, no planets, no dust holds something, a fabric, a structure, a frame so subtle we barely notice it. Long ago, some imagined a mysterious medium called the ether, a ghostly substance filling space, something light could ripple through, like sound through air, like waves through the sea. But no matter how we searched, the ether never revealed itself. No wind blew through it, no pressure shifted, and eventually we realized it was never there. Because space doesn't need a medium for light to move. Space is the medium. Let's think of it this way. You're holding a soft, endless sheet of silk. When you flick one edge, a ripple moves outward. But what if the silk isn't made of threads? What if it's made of laws? Not fabric, but geometry. Not fibers, but rules about how distances work, how directions bend, how time connects with motion. Light doesn't ride on top of this. It rides within it, carried not by particles but by the very structure of the cosmos. And here's where it becomes dreamlike. The structure of space itself only allows one speed for something massless to travel. One, not a range, not a ceiling, a precise dictated value, like the tension on a perfect string, like the rhythm in a lullaby. That speed then, the speed of light, is not just about photons. It is a property of the universe. It is how space tells time how to tick, how distance gets measured, how cause becomes effect. You're floating now, just above that infinite sheet. You press your hand down and feel nothing. But if you flick a finger, if you call forth a beam of light, the fabric shivers at exactly one pace. Never more, never less. It's not that light wants to go at that speed. It's that when space is empty and untouched, that's the only rhythm it will allow. Imagine you're on a train made of nothing but thought. The train has no engine, no wheels. It moves only because space agrees to let it. You're not pushing it. You're being carried, and the speed is already chosen. That's what it means for light to move through space. Now, consider what happens when that space curves. When a planet rests in space, it warps the fabric around it, not like a bowling ball on a trampoline, but more like a whisper curling in water. And when light passes near it, it follows that curve. Not because it's pulled, not because it's attracted, because space itself has changed shape, and light, like a violin string across that silk, can only move where the fabric permits. So it bends. It arcs around stars, veers near galaxies, dances along the folds of gravity. Not as a ball thrown off course, but as a traveller on a road that curves without asking permission. We call it the bending of light. But it's not light that bends, it's space. You and I, resting together in this soft laboratory of thought, might begin to see light not as a traveller, but as a message from space to itself, a message shaped entirely by the path it must take and the pace it cannot change. And now, a soft question, barely a breath. If the fabric of space is what determines how fast light can travel, could that fabric ever change? The answer, slow and strange, is yes, but only under extraordinary conditions. There are whispers in the equations, in the edges of black holes, in the first instant after the beginning of time, where space may have behaved differently, stretched more tightly, vibrated faster, but those are dreams for another night. For now, we linger here, in a universe that holds steady, that lets light glide across the dark, not because something pushes it, but because the rules themselves are constant. That constancy, that limit, is not a cage. It is a signature, an identity. And so we rest, knowing that when we next look up at the stars, we're not just seeing across distance, we're reading the rhythm of space itself carved in light. The teacup doesn't move, it floats gently in the middle of the room, steam rising in slow spirals, sugar unmelted, as if time itself has chosen to pause. And in this stillness, we recall a thought that changed everything, whispered by a quiet man with wild hair and soft eyes. Einstein never shouted. He didn't storm the gates of science. He simply asked a question, as quietly and curiously as you might be asking it now. What if the speed of light is the same for everyone? At first, it seems like nonsense. How can that be? If you run toward a beam of light, shouldn't it come at you faster? If you run away, shouldn't it fall behind? That's how everything else behaves. Throw a ball on a moving train. It goes faster or slower depending on how you move. Walk through the rain. It hits differently depending on your direction. But light does not change. No matter how fast you go, how far you lean, how determined your motion, the speed of light remains. Always the same, always the limit, always the rule, even if you're moving toward it, even if you're racing away. Einstein imagined himself chasing a beam of light, a quiet child on a bicycle drifting through a dream. What would he see, he wondered, if he caught up? Would the beam stop? Would it freeze in place, a shimmer stuck in mid-air? But no, the math wouldn't allow it. The universe wouldn't allow it. Because if the beam did stop, if you could see frozen light, then the electric and magnetic fields that form it would have no motion to sustain each other. They would vanish. They wouldn't be light anymore. And so, no matter how you chase it, light always slips just out of reach. The speed of light is not just fast, it is fixed, not relative, not subjective, fixed in the way a lullaby has a rhythm or a heart has a beat. To keep this truth, though, the universe has to do something strange, something so subtle we rarely feel it, and yet so profound it touches every second of your life. It bends time, it folds space, all to keep the speed of light the same for everyone. Let's linger in that thought. You and a friend stand apart, facing each other in the meadow. You shine a beam of light toward her, and she catches it, perfectly timed, perfectly placed. But then she begins to walk, then run, then fly. Still, she sees the light come at her exactly the same. Still, you see it leave you exactly the same. To preserve that illusion, no, that reality, time itself must stretch for her. Distance must change. What once was 1 meter becomes something softer, less certain. What once was a second becomes elastic. This is not a trick. It is how reality keeps its promise. To preserve light's perfect pace, the universe alters everything else. Speed, after all, is distance divided by time. If speed cannot change, then time and distance must shift to compensate. Like dancers keeping their timing even as the floor tilts beneath them, and that's what Einstein showed us. The speed of light is not just a rule of light, it's a rule of space, a rule of time, a rule of cause and effect. Now we return to the teacup still floating, a symbol, a reminder. The reason it does not fall, not yet, is because we are inside a thought experiment, a chamber where gravity sleeps, where motion is unclear, where only light reveals the truth. We flash a beam across the room, wall to wall. If the chamber moves, the beam appears to angle slightly, but no, it doesn't. It can't. To keep the speed of a light the same, the chamber's clock must tick differently. A second here is not a second there. We begin to drift, not in the chamber, but in understanding. Reality, it turns out, is not absolute. There is no universal now, no shared time, no master clock. There is only agreement, delicate, mathematical, tender, that light speed will be constant and everything else will bend around that truth. Somewhere outside this experiment, the stars are watching. Their light took thousands of years to reach us, but it arrived without error. Because across all that time, across all that curved space and stretched distance, the rules never broke. Time bent, space curved, but the speed of light held steady. It always does, because without it, the rhythm would fail, and the teacup would fall. Let's leave the chamber now. The walls dissolve behind us, soft as paper folding into fog. We step out into a wide open space, a meadow perhaps, or a desert at twilight. The sky is dim, streaked with the colours of late daydreams, and above us, shadows stretch long and thin. Not the shadows of things, the shadows of motion. You begin to move, first slowly, then faster. You walk, you run, you glide without effort, like thought unchained. You pass trees, clouds, time. But the strangest thing is this. No matter how fast you go, the light in front of you does not grow closer, and the light behind you does not fall away. It moves beside you, as if the shadows themselves are racing with you, locked at that same perfect pace. You speed up again, pushing now, though there's no wind, no sound, just motion. You move so fast the stars seem to bend. But still, the beam of light in front of you holds its distance. You cannot catch it. You cannot change its speed. You cannot fall behind. This isn't failure. It's something deeper, something absolute. Light moves the same, always, for everyone. And because of that, motion itself must change. The faster you go, the stranger time behaves. The faster you go, the more space folds. But always, light remains, untouched. Let's imagine something. A spaceship, slender as a feather, silver as a sigh, glides through the black. You're inside it now. There's a mirror at the floor and another on the ceiling. A beam of light bounces between them, down, up, like the ticking of a clock. This is your time. Tick, tock. One beam down, one beam up. Now someone watches from outside, someone floating still, while you drift past at impossible speed. From their view, the light no longer moves just up and down. It moves in a diagonal, a zigzag, because the mirrors are moving sideways and the beam must chase them, a longer path across each tick. But here's the key. Even though the path is longer, the light speed is unchanged. It cannot move faster. So for the beam to take this longer journey at the same speed, time itself must slow down for you. That's what the outside observer sees. Your clock ticking more slowly. Tick. Pause. Tock. This is not an illusion. This is how motion works when light holds steady. Every movement changes your relationship with time and space, because they are not separate things. They are threads in the same cloth, and the faster you go, the more they stretch, like fabric tugged at the edge. This is called time dilation. It happens not just in thought experiments, but in real machines, in orbiting satellites, in GPS systems that must account for the tiny warps of time caused by their speed. because otherwise they would drift and get lost. Even planes flying high in the sky experience it, though the effect is minuscule. A clock in the air runs a tiny bit faster than one on the ground, where gravity tugs harder, and all because of the rules we whisper about tonight. Now close your eyes. Imagine you could move at the speed of light. What would you see? The answer is nothing, because you couldn't see at all, not even in theory. You would become light, and light does not age. It experiences no time, no duration, no before or after. From the moment it is born, in a spark, a star, a thought, to the moment it is absorbed, its journey takes no time from its own point of view. It leaves, it arrives. There is no between, and you, a creature made of mass, can never go that fast. Because as you approach the speed of light, time stretches thinner and thinner, your energy increases, your mass increases, and the closer you get, the more the universe resists. It would take infinite energy to reach that speed, a boundless effort, an impossible push. That is the limit, not by law, but by geometry, not by punishment, but by structure. We are made for slowness, for gradualness, for aging, for patience, for clocks that tick and hearts that beat. But light is outside that story. It does not race to win. It simply is, constant, final, perfect. So you stop now, resting again in the grass. Your breath is slow. The shadows return to their usual lengths. The stars overhead drift calmly, whispering truths in the language of silence. The race never was about speed. It was about understanding what cannot be outrun, and why. The meadow is quieter now. Even the wind seems to have fallen asleep. Your thoughts drift, feather light, as the stars above watch gently from their timeless perches. In your mind's eye, a clock floats. It's a strange one, a perfect sphere, suspended in the air, its hands slow and golden. You float beside it, not pushing, not holding, just drifting. It ticks once, then again, softly, like a breath exhaled. This is your time, but then you rise, upward, slowly at first, then faster, ascending into the upper stillness. And as you rise, something curious begins to happen. The clock below ticks, differently, not broken, not wrong, just slower, as if it were falling asleep, 1 second at a time. This is gravity's lullaby. The deeper you are in a gravitational field, on Earth's surface for example, the slower time moves compared to someone floating high above. It's not dramatic, but it's real. A clock on a mountaintop runs just a bit faster than one at sea level. It's not your imagination. It's not illusion. It's the gentle stretching of time by mass. Mass bends space, and when space bends, time follows. Always. Like a ribbon that can't help but curl when the surface beneath it warps. Now let's return to that floating clock. Imagine placing it inside an elevator, one that's not tethered to anything. It's drifting, weightless, in the black between stars. You and the clock, alone in the silence. Suddenly the elevator begins to fall. Not down, there's no down out here, but toward a massive planet far below. You don't feel the motion at first. There's no shaking, no jolt, just the gentle sensation of weightlessness. You glance at the clock. Its hands still move, but something changes in your perception. The beam of light you shine from one wall to the other now lands slightly lower, not because the beam is bending, but because the elevator is falling as the light crosses. From your point of view, the light curves downward, but light always moves straight. So how can it bend? Einstein answered this with one of his most elegant insights, the equivalence principle. He said, "Being in a closed box accelerating upward feels the same as being in a gravitational field. To the person inside, there's no difference between standing still on Earth and accelerating upward through empty space. That simple, soft idea led to something profound. Gravity isn't a force, pulling things down like strings on a puppet. It's the warping of space and time. Mass tells space how to curve. Curved space tells objects how to move. And time, always obedient, ticks in agreement, bending where space bends, stretching where mass resides. Light, too, follows these curves. Not because it wants to, not because it's being pulled, but because the path it takes, the straightest possible line, is now curved. This is why light bends near stars. This is why time passes slower near massive planets. This is why the floating clock ticks differently depending on where it floats. We once thought of gravity as a force, but now, here in this whispered place, we know better. Gravity is geometry. It is the shape of existence, and the speed of light, ever constant, helps us measure that shape. Imagine shining a beam across the elevator, again and again as it falls. Each time it appears to curve more, not because the light is failing, not because the beam is wrong, because motion reveals truth. As the elevator descends, it accelerates, and inside, time begins to shift, slightly, subtly. You and the clock share a bond, but the bond grows stranger as you fall deeper into gravity's arms. We ask, what happens if the elevator never stops? What if it falls into a black hole? Where would the light go then? Would it curve forever? Would time stop altogether? These are questions for later. Quiet seeds we'll plant now and visit again at the edge of the script. For now, we return to gentler curves, to the world where gravity is not a trap but a pillow, a soft warping of reality that lets galaxies spin, lets planets cradle moons, lets apples fall and clocks drift out of sync. In every curved second, light still travels at the same speed, but its path is no longer straight, and so we float beside the clock once more, not watching time, but watching how it watches us, bending and stretching as softly as a yawn before sleep. Now the elevator has vanished, not with a crash, but with a sigh. We find ourselves suspended in nothing at all, a place between thoughts, between weight and motion. Here, gravity is silent and space is smooth. You're not falling, not flying, just floating, and beside you, a mirror. It hangs in the void, gleaming with stillness. You look into it, and what you see is not your reflection, but light. A beam, travelling toward the mirror and bouncing back. You send it out again, soft, steady pulses like the rhythm of breath. Each one returns, each one marks a moment, a heartbeat in the dark. Now, imagine this. You begin to accelerate, not a jolt, not a blast. A slow, endless drift that becomes faster, then faster still. You're moving forward, but there is no wind, no resistance. Only the mirror, now slipping behind you. The beam of light you send out seems to take longer to return, and the next, longer still. Because as you move, space shifts, time stretches, not in front of you, behind. And then you realize something odd. Even though you feel motionless, no gravity, no vibration, the light keeps changing, not in speed, not ever in speed, but in frequency, in direction, in the way it returns to you, because you are accelerating, and to the light that matters. You shine another beam forward toward where you're heading. It returns to you, compressed, bluer, more frequent. Behind you, a beam sent backward returns stretched, redder, slower. This is not weather. This is not illusion. This is the universe's way of whispering, you are moving. Not in space, but in relationship to light. and light. That constant rhythm now tells you how far you've gone. The mirror continues to drift farther behind. The pulses take longer, and though the speed of light remains untouched, your understanding of motion begins to deepen. Motion, you see, is not about engines or effort. It's about perspective. You can feel acceleration. You can measure it. But once you reach a constant velocity, even if you're moving faster than sound, faster than bullets, there is no experiment inside your capsule that can tell you you're moving at all, unless you use light. Light always reveals the truth. It does not lie, but it also does not accuse. It simply reflects what is. A photon bouncing back and forth in a box reveals how space is stretching, how time is bending, how motion quietly changes your frame of reference. Now, imagine the box again. This time, it's falling, not accelerating upward, not drifting, but truly falling. The kind of falling where everything inside feels weightless. You, the mirror, the light, all are falling together. And here, something beautiful happens. The light returns to you in perfect rhythm, no redshift, no blue, because everything is moving in harmony. This is free fall, and it is indistinguishable from stillness. This is Einstein's great insight again. Acceleration and gravity are the same when you're sealed inside a box, and light, constant, unwavering light, is how we know. This is how we detect gravity, not by feeling it, but by measuring how it bends light. And so, the mirror becomes more than a surface. It becomes a tool, a way to ask the universe the softest questions. How fast am I moving? How strong is the gravity here? Is this falling or floating? Every answer is hidden in light's return. Let's step away now. The box fades, the mirror too, but the lesson remains, soft as starlight, deep as sleep. Light's constancy reveals everything that shifts. If time changes, light shows it. If space curves, light obeys it. If you accelerate or fall, light traces that motion with absolute elegance. Even when you cannot feel the motion, even when you think you are still, light will tell you the truth. A truth without blame, without noise, without judgment. Only rhythm, only return, only light. You are motionless again, or so it seems. There is no breeze against your skin, no scenery gliding past. You sit beneath the imagined stars, head tilted, breath steady, a part of the stillness. But somewhere beneath this silence, a question pulses, low and patient. What does it really mean to move? Let us explore. You raise your hand, slowly, through the air. It feels simple, obvious. But in truth, every motion you make is a story told by the universe, a rearrangement of coordinates, a dance of particles shifting their place on the invisible grid of space and time. Yet nothing ever moves alone. Motion is always measured against something. You move your hand relative to your body. Your body moves relative to the Earth. The Earth spins beneath stars. The stars drift through the galaxy. The galaxy tumbles through the cosmos. Everything is always in motion, but only ever in relation to something else. Now imagine this. Two ships, far from any stars, any planets, any noise. They drift side by side in the deep black. No windows, no engines, no clues. From the inside they feel still. But then, a flash. A beam of light travels from one ship to the other, and when it arrives, it tells a secret. One ship is moving just a little, not because it can feel it, but because the light took slightly longer than expected. Light reveals the shift. But here's the paradox. Even though both ships send light, and both see it travel at exactly the same speed, each may claim the other is in motion, and they'd both be right, or wrong. Because in this universe of woven time and elastic space, motion is relative. There is no absolute stillness, no ultimate reference point, except for one, light itself. Unlike anything else, light is not measured relative to something else. It always travels at the same speed, for all observers, no matter how fast they are moving, no matter what direction they face. It's the anchor point, the heartbeat, the universal rhythm that never changes. And because of this, it becomes the boundary, a speed that no object with mass can reach. Let's rest on that thought. You, your body, your atoms, your memories, all have mass. It gives you substance, presence, a kind of gravity, but it also gives you inertia, the quiet resistance to change. To push you faster takes energy, more and more as you approach the speed of light. And the math whispers something quietly. You can never quite get there. Every push brings you closer, but the energy required grows, doubles, triples, becomes infinite. And infinity is not a number you can carry. It's the universe's way of closing a door gently but firmly. Now, imagine again, a train moving fast, a flashlight switched on at the front. To someone standing on the tracks, the beam moves away at light speed. To someone on the train, it does the same. The train speed does not add to the lights. This would break all our rules, distort space, fold time in impossible ways, and so the rules hold. Because light doesn't play by the same game, light has no mass, and for this reason, it's not just fast, it's fundamentally different. It moves not because it was pushed, but because it cannot do otherwise. It does not rest, it does not pause, it does not age. You begin to see it now, why nothing outruns light, why it is not a ceiling of speed, but a horizon of possibility. Anything with mass, anything that exists in the traditional sense, must begin with stillness, must be accelerated, must fight against inertia. But light begins with motion and never stops. It was never still. It never will be. And because of this, it defines the edge of what we can see, the edge of what can influence, the edge of cause and effect. You can move fast, you can build rockets, dream dreams, race through time itself. But the speed of light will always stay ahead, not mocking, not taunting, just constant. A reminder of the structure that holds it all together. And so you lie back again, the stars above unchanged, the meadow soft beneath you. Everything moves, and yet, in this moment, nothing rushes. Even light, with all its speed, does not hurry. It simply goes. And we, the slower beings, listen to its story in every sunrise, every reflection, every quiet, glowing thought. Let's return to the light, not the soft beams drifting through the trees, not the warm glow of fireflies or lanterns or suns, but the smallest flicker possible, the particle of light itself, the photon. You can't touch it, you can't see it alone, but it exists, pure, massless, indivisible, and it is always moving, always at the same speed, never more, never less. And here is the deepest wonder of all. The photon has no resting place. It cannot slow down, it cannot stop. You and I, we pause between steps, we rest, we sleep, we sit still in silence. Every object with mass has that privilege, a moment of stillness, but a photon, it has no mass, and so it is never still. Not because it's impatient, not because it's in a hurry, but because the laws of the universe give it no choice. To exist as a photon is to move at the speed of light, and this has a strange consequence. From your point of view, a photon takes time to travel. A beam from the sun takes 8 minutes to reach Earth. A photon from a distant galaxy might travel for billions of years before it arrives in your eye. But for the photon, time does not pass, not even a second. It is emitted, it is absorbed, but it experiences no during, no journey, no distance. This is not a metaphor. It is not a philosophical thought. It is what the equations say, what the geometry of space and time insists. From the photon's point of view, everything happens all at once. What does that mean? It means that light, for all its speed, does not travel through time. It exists outside of time, or perhaps more precisely, it rides the very edge of time where the forward march of seconds slows to stillness. Let's try to feel this. You stand at the edge of a still pond, watching a ripple begin. Now imagine the ripple moves across the surface, not slowly, but instantly. You drop the stone, and the wave appears at the far shore the very same moment. To you, that's impossible. But to the ripple, to the photon, there was no delay, no waiting, no middle. This is how a photon lives. And now we return to why this matters. Light is the fastest thing in the universe not because it's powerful, but because it has no mass. That absence, that lack, is its freedom. But it is also its constraint. Because to move at the speed of light, a particle must have zero mass, no exceptions. If it had even the smallest amount, it could not travel that fast. The rules would push against it. The energy required would become enormous. This is why electrons, though small, do not move at light speed. Why neutrinos, though strange and elusive, fall just short. Only massless things, light and a few other quantum whispers, can reach the ultimate velocity. This is the rule that defines the structure of everything. Imagine now a sea of photons, not in motion, but existing, moment by moment, all across the universe. Some are born in stars, some in light bulbs, some in your phone screen, and every one of them moves instantly at the same speed. This creates more than light. It creates causality. Because nothing can move faster than a photon, information cannot move faster either, and that, gently, firmly, sets the boundary of what can influence what. Cause and effect. If something happens here, it cannot affect something over there before light could get there. To do so would break the logic of the cosmos. It would be like hearing an echo before you speak, seeing a shadow before the object. The speed of light, then, is not just a speed, it is the edge of influence, and the photon, always moving, never pausing, is the keeper of that edge. You close your eyes. Somewhere, right now, a photon is striking your skin. It began its journey in a star, maybe even one older than your world, and from its perspective, that journey took no time at all. Just birth, then touch, no aging, no in-between. Perhaps that's what makes light so timeless. Not its brightness, not its warmth, but its refusal to linger. It does not look back. It does not slow down. It simply is. And we, slow, breathing creatures, are left to wonder what it means to live so fast you outrun even time. The air around you hums with stillness, and yet somewhere beyond your reach, the stars continue their long conversations in silence. Their language, light, their rhythm, constant, their boundary, unbreakable. We now approach the heart of it. The speed of light is not only the pace at which photons glide, it is the maximum, the ultimate, the speed limit of the cosmos. But why? Why should there be a limit at all? Everything else seems scalable. Heights, depths, temperatures, sizes, all stretch across ranges. But speed? There is a ceiling, a final number, a hard stop. 299,792,458 meters per second. The question is not why light goes that fast. The question is why nothing can go faster. Let's begin softly. Imagine you're floating in space again, free of gravity, free of motion, or so it seems. You begin to move, not with a push, not with a shove, but with thought. You glide, then accelerate. Faster now, even faster. As you speed up, things begin to change, not around you, inside you. Your sense of time warps, moments stretch, the clock you carry ticks slower. Your heartbeat spreads out, drawn thin across this new velocity. Your mass increases, not in bulk, but in resistance, in the effort it would take to push you faster still. The universe starts pushing back, not violently, but absolutely. And as your speed approaches the speed of light, the resistance approaches infinity, not figuratively, literally. The energy required becomes limitless, and so, you cannot reach it, you cannot exceed it. The limit is not a wall you crash into, it is a horizon you never reach. This is not a flaw in physics, it is a feature, a necessity. Because the speed of light is built into the very equations that define space and time. In Einstein's theory of special relativity, this speed appears everywhere, not as a quirk of light itself, but as a structural constant. If you removed all light from the universe, the speed would still be there, because it is not the speed of light. It is the speed of causality, the maximum pace at which one event can influence another. Let's return to the pond. You drop a pebble. Ripples move outward. That's causality. An event, the pebble, creates effects, the ripples. But those ripples can only move so fast. If something farther out reacts before the ripple reaches it, something is wrong. In our universe, the ripple is light, and the ripple can never be passed. To go faster than light is to allow causes to trail effects, to let messages arrive before they're sent, to break the order that gives meaning to time. This would shatter everything, not just our physics, but our experience, memory, prediction, reality. And so, gently, firmly, the universe says, no faster. There are particles in theory called tachyons, hypothetical travellers that move only faster than light. But we've never seen them, never caught even a whisper of their passage. And if they did exist, they would defy causality. They would break the silence between cause and consequence. They remain dreams, mathematical ghosts. Let's imagine, though, just for a moment, that you could send a message faster than light, perhaps to a distant star, or to your own past. You might receive a reply before you ever sent your question, a birthday card before the birth, a warning before the event. This is not just paradox, it is collapse. The structure of logic would erode, and so the universe holds firm. The speed of light is not just about how fast photons travel, it is the scaffolding of consistency, the guarantee that events remain in order, that clocks move forward, that reality behaves. Now rest with this truth. The speed of light is not arbitrary, it is not imposed, it is revealed, a signature of the relationship between energy and space, between time and motion, between what is and what can be. You roll over gently in the grass. The stars above remain distant, yet their light reaches you, unhurried, unchanged. Some of it began its journey before your world was formed, and yet it obeys. Every beam, every spark, every pulse, not one has broken the limit, not because they are weak, because they are real. Close your eyes and picture the stars once more, not as points of light, but as silent messengers. Their glimmers drift across the void, bringing us stories not from the present, but from the past. Ancient echoes, delayed whispers. That delay is everything. It is not an inconvenience. It is not a flaw. It is the fabric of how we know, how we think, how we even exist. The speed of light sets not only the pace of motion, it sets the boundaries of information. How fast a signal can travel, how quickly one thing can affect another. It is the speed limit of knowledge. Now imagine something close, your thoughts. An idea forms in your mind. A message travels from one neuron to another. It feels immediate. But even your brain, that most intimate instrument, must obey time. Electrical impulses travel along nerves, but never faster than light, not even close. The fastest messages in your body travel slower than a slow breeze compared to light. Now scale outward, from mind to machine, from thought to data, from satellites in orbit to probes at the edge of the solar system. Every bit of information, every ping, every picture, every pulse takes time, and this time is shaped by distance. Let's imagine you send a message to Mars, a simple hello. That signal, travelling as a radio wave, moves at the speed of light. Yet it still takes several minutes to arrive. No matter how urgent the message, no matter how powerful the antenna, you cannot make it go faster, because it is not the device that limits the message. It is reality itself. The space between objects stretches that message, forces it to crawl, not in slowness, but in obligation to the limit. And this changes how we interact with the universe. We can only see what light has had time to reach us from. We can only affect what lies within our light cone. The region of space where, given enough time, light from us could travel. Outside that, it is unreachable, not just physically, causally. You could aim your most powerful laser at a galaxy so distant that its light hasn't yet reached us, and it wouldn't matter. The laser would never get there. The space between expands too fast. The moment has already closed. Even light cannot reach all things. So we begin to understand. The speed of light is not just a number. It is a border, a horizon around every moment. You are always inside a sphere of influence, the things you can affect and the things that can affect you. That sphere grows as time passes, but it is bounded by light. No faster thought, no faster signal, no faster change. There's something comforting in this limit. It forces a kind of patience. It ensures that the universe unfolds gradually, like a story told page by page, never skipping ahead. It also means we're always seeing the past. Every sunrise is 8 minutes old. Every star you wish upon may have burned out before your grandparents were born. Even the moon, so near, speaks to you with a delay of over a second. And still we listen. Still we reach. Still we send messages into the dark knowing they'll take years, centuries to arrive. Because the universe may be vast, but it speaks in light, and light speaks in time. Now breathe slowly. Let this idea soften into you. You will never know anything faster than light allows. No thought from the stars will arrive early. No glimpse of the future can outrun the now. This might feel like a prison, but it's not. It's a stage, a rhythm, a reason that cause precedes effect, that memory has meaning, that time flows. And so, next time you flicker a lamp, or send a message, or look up at the sky, remember, light is not just travelling, it is carrying possibility, and doing so at the only speed that lets the universe make sense. You sit now in a room of mirrors. They stretch endlessly in every direction, reflecting one another, fractal upon fractal, horizon upon horizon. Each reflection arrives slightly after the other, just a fraction of a second later. And in that imperceptible pause, a truth lives. Everything you see is delayed. Even your own reflection, The light from your face bouncing to the mirror and back to your eyes took time to return. The delay is too small to notice, but it is there. The world is not immediate, it is always late. Every glance, every scene, every colour is light arriving from somewhere else, some then that we experience as now. The moon overhead, you see it as it was over a second ago. The sun in the morning sky, you feel its warmth from 8 minutes in the past. And the stars, ancient, their photons began before your species did, before your language, before the earth knew your name. You're not looking at the present, you're looking at a sky filled with memories. The entire world is built from delay. This is not a metaphor, it is not poetic framing, it is physics. There is no such thing as seeing something as it is right now, unless it is happening inside your eye. And even then, the processing of that information is slowed by the pathways of the brain, electrical, chemical, physical. What you perceive is always a reconstruction, a recent history. Reality is not immediate, it is interpreted, and that interpretation begins with light. Let's imagine something simple, a candle flickering in the dark. You watch its flame, soft and golden, but the glow that reaches you is from just a few nanoseconds ago, delayed by the time it took those photons to cross the air. It is imperceptible, but scale up the distance, a person across the field, a signal from a distant rover, a galaxy at the edge of the observable universe. That delay grows until it becomes time itself. We do not live in an instant, we live in a cascade of arrivals, and what's more, those arrivals are not all equal. Some photons travel through dust, some through gravity, some are bent, some are stretched. What you see is a patchwork of light's many journeys, each one altered by the road it took, and yet we treat them as a snapshot, as the now, because we must, because otherwise the world becomes too fragmented to hold in a single thought. But physics does not lie. It tells us that now is not a shared moment across space. There is no universal present. You and someone a light year away do not share the same slice of time. You can try to define one, but relativity will slip the rug from under you. The faster you move, the more skewed your experience of time becomes. Events that are simultaneous to you may not be to someone else. This is the sleep of simultaneity, a world where the present is not a plane, but a blur, and light, unwavering, relentless, enforces it. The speed of light forces us to reckon with the idea that information always travels across time, that you never truly see anything as it is, only as it was when its light began moving toward you. But there's comfort in this too. You're surrounded by echoes. Each glimmer is a message. Every sight is a connection across time. Even your own shadow is a delay. The light that passed you, that bent around you, that failed to reach where it might have, leaves a darkness behind that tells a story of where you were, what you blocked, how you stood. So yes, everything is late, but that lateness is consistent, predictable, beautiful. It means that our universe does not flicker or jump. It flows, and that flow depends on the speed of light. Not infinite, not immediate, but just right. Just slow enough to preserve order, just fast enough to reveal the past. You stand now among the mirrors once more. Each reflection is slightly older than the last, a corridor of memory, built from the simple fact that light moves at a finite speed. That slowness, that's what allows the world to unfold. Time is not what it used to be, or rather, it's never been what we imagined. We once thought of it as a river, steady and shared, flowing in a single direction for all, a universal clock ticking behind the curtain of the cosmos. But then came the realization, quiet, patient, unsettling, that time doesn't move the same for everyone. And the reason, once again, is light. Let's return to a thought we barely touched. Simultaneity. The idea that two events can happen at the same time, even if they are separated in space. A bell rings in the distance, and a light flashes nearby. You see them both. You say, they happen together. But what if you were moving, not walking but gliding smoothly, in a train that stretches across a quiet plain? Now the same bell, the same flash, but from your new motion, one seems to happen before the other. Which is correct? Both? Neither? Because simultaneity is not absolute. It is dependent on your motion, on your frame of reference. And since light speed is always the same, the only way to preserve that constancy is for time itself to adjust. A light flash in the center of the train may reach both ends at the same time, but only if the train is still. If it moves, the rear of the train rushes toward the light, while the front slips away. The beam reaches the back before the front, and to the person standing outside that makes sense, but to the person inside the light traveled the same speed in both directions, so they must conclude the flashes did not start at the same time. Two observers, one event, two different nows, and neither is wrong. The faster you move, the more warped your experience of time becomes. This is not due to perception. It's not psychological. It's physical. Let's lie back again, on the grass that doesn't grow, under the stars that don't age. Imagine two friends, one on Earth, one in a spacecraft hurtling near light speed. They synchronize their clocks. At first, all is well. Each second matches the other. But then, as the traveller accelerates, time bends. Not for one more than the other, but differently for each. The traveller's time begins to flow more slowly, like syrup instead of water. Their seconds stretch, their moments lengthen, and when they return, years later on Earth, their own clock has ticked only a handful of times. This is not fiction. This is not a guess. This is time dilation, a real, measured, confirmed phenomenon. One that lets astronauts age slightly less than those on Earth. One that turns particle accelerators into time machines, where subatomic particles live longer simply because they're moving near the speed of light. And all of it flows from one truth. The speed of light is constant. Because it cannot change, space and time must. They are not fixed stages but flexible threads. Motion twists them, gravity warps them, and simultaneity, it becomes soft, relative, fluid. There is no shared now stretching across the stars. Your now is yours, mine is mine. The light from a distant galaxy, reaching your eye tonight, began its journey before Earth formed, and yet, from your point of view, it arrives now. Is it in the past, or have you just met it in its present? The answers blur, but in that blur is beauty, because it means the cosmos is not static. It's stitched together from viewpoints, frames of reference, a quilt of realities, each sewn from light and time, and light, always faithful, travels between these perspectives, unchanged in speed, yet transformed in meaning. That is why light's limit defines the shape of possibility. It doesn't just constrain how fast things can go. It shapes how time works. It defines which events can influence which others. It defines which clocks agree and which drift apart. You see now, without the limit, time would fracture. Causality would erode. Stories would crumble. But because of the limit, everything holds, even if it bends, even if it slips, even if your now is not my now, it still makes sense. We still meet, here, in the shimmer between seconds, and now the stars begin to stretch, not with speed, but with silence. You feel it, not a breeze, not a sound, but a drifting, like the horizon itself is slowly pulling away from you. Galaxies recede, not because they are flying through space, but because space itself is growing between you. This is expansion, the quiet, persistent stretching of the fabric of the cosmos. We often imagine the universe like a balloon inflating, not perfect, but close. The galaxies are not dots flying outward, they are beads on the surface, and it's the surface itself that's expanding. And in that growth, light must still travel, still obey the speed limit, still follow the same patient pace. But space plays a trick, because while the speed of light remains constant, the space that the light must cross is increasing as it travels. A photon released from a distant star may begin its journey across millions of light years, and in the time it takes to reach us, the universe stretches further beneath it. The path grows longer, so light takes longer to arrive, and when it does, it is tired. Not in the human sense, not weary or dim, but stretched, its wavelength elongated by the expansion of space itself. Redshift, the ancient fingerprint of an expanding cosmos. And so, we don't just receive light, we receive messages altered by the growth of the universe, slowed, softened, shifted, like an echo distorted by the canyon walls. Now imagine standing at the edge of that expansion. You shine a light, but the space between you and your target grows so fast that the light never arrives. Not because it's too slow, but because the destination is moving away faster than light can close the gap. This is the cosmic event horizon, a boundary beyond which we will never see. Not because light fails, because space wins. The universe is not just expanding, the rate of expansion is increasing, and there are galaxies today whose light, no matter how long we wait, will never reach us. Not ever. The space between us grows too fast. They have slipped beyond our light cone, outside the realm of causality. And so again, the speed of light defines what is knowable, what is reachable, what is ours to see. It is not just a speed, it is a fence, a gentle boundary between the part of the universe that can still speak to us and the part that has gone quiet. But there's something more, because the light we do receive, the ancient light from billions of years ago, is telling us not just where things were, but how space used to be. We're looking at younger versions of galaxies, of structures, of reality. The farther we look, the further back we see, because the journey took time, because space stretched along the way, and that stretching, it tells us about dark energy, the strange force behind the accelerated expansion, a mystery still unsolved, a whisper in the equations, something that pushes instead of pulls, something that deepens the divide. But even here in this vast changing cosmos, the speed of light remains unchanged. It is the thread that still ties now to then. It is the ruler by which we measure growth. It is the scale on which distance becomes history. Time becomes colour, and space becomes story. Now breathe. Let that truth settle in your chest like the light from a far-off star settling in your eye. We will never see everything. We are bounded by light's patient pace. But within that boundary lies all meaning, all memory, all message. Even as the universe stretches and slips away, what light can reach us will, and in each beam, an origin long ago. A journey made possible not in spite of the limit, but because of it. Let's leave the great galaxies for now. Let the stars fade. Let the cosmic horizon fall silent. We're descending, down, down, past the familiar scale of things, past atoms and electrons and into the jittering, restless ocean beneath reality. This is not space as you know it. This is the quantum foam. It seethes, it flickers, it never rests. Even in a perfect vacuum, utter darkness, absolute zero, total stillness. This foam churns with activity. Pairs of particles and antiparticles blink into existence, then vanish. Energies rise and collapse again before time can even properly record them. They are not mistakes, they're not interruptions, they are the groundwork of everything. And in this realm, light still moves, but not like before. Here, the path of a photon is not a straight line. It jitters, it swerves, it twitches, not because of chaos, but because of quantum uncertainty. The very fabric of space is alive with fluctuations, and light must navigate this invisible sea. So what does it mean to have a speed limit here? What does it mean for something to move at exactly the same rate through a realm that refuses to stay still? The answer lies in statistics, in law, averaged out over immense scales. The photon's path may jitter, but its average speed across long distances remains perfect, constant, reliable. You might walk through a storm, buffeted by winds, distracted by flashes, but still arrive at your destination right on time. That's light in the quantum world, always on time, even if its feet never touch the ground the same way twice. And in these depths, where the vacuum itself is not truly empty, light interacts. Not often, not enough to stop, but enough to matter. Enough that its speed could, in theory, be influenced. And yet, it isn't. Not in any way that violates the limit. Because that limit is not just about light. It's about what space allows. It's baked into the equations of quantum field theory. The vacuum fluctuations, the virtual particles, the fields, they all operate within a framework that upholds the speed of light as the upper bound. Nothing moves faster. Even these quantum whispers obey. Now imagine this. A photon travelling across the void for billions of years, passing through clouds of gas, brushing by gravitational wells, whispering through quantum foam. And at every step, despite the chaos beneath it, it holds its pace. It does not get tired. It does not slow. It does not yield to the fluctuations. Why? Because the speed of light isn't simply the behavior of light. It's the character of space-time itself. It's not that light moves through a jittery ocean. It moves as part of it. It dances in perfect rhythm with the foam, never outracing it, never lagging behind. It honours the structure even in the most unstructured realm. And here's something even more astonishing. When scientists measure the speed of light, they don't just use photons, they use the properties of the electromagnetic field, its permittivity and permeability, constants that define how electric and magnetic fields interact. And from those, they derive the speed. It emerges from the rules of interaction, from how the fabric bends and responds to energy, from how quantum fields breathe. So the speed of light is not just a number we observe, it's a consequence, an inevitable result. Like waves on water having a certain speed because of water's density and tension, light has its speed because of how space is, even here, even in the jittering vacuum, even in the places where nothing is full of potential. So close your eyes. Picture that photon again, quiet, quick, relentless, not moving through emptiness, but threading its way through a living sea, unhurried, still at the limit, still at the edge, not despite the chaos, but because of it. You're floating now, far beyond the edge of scale. There are no stars, no planets, no clocks, just silence, just dark. But in that dark, something glows, faintly, silently. It is not a thing, but a motion, a thread, a photon. It has travelled across time itself to reach you, unchanged in speed, untouched by rest. You do not see it, not with eyes, but you feel it. It arrives with a whisper that contains a secret, not about where it came from, but when. This photon, like all photons, carries direction, yes, carries energy, yes, but it also carries history, a record, an arrow, a way of knowing which way time is flowing. Because time, as strange as it behaves near mass and motion, still moves in one direction, and light obeys, always forward, never back. But why? Why can light only move forward in time? Why can we only receive the photon, never send one into the past? This is the question of time's arrow, and tonight we follow the photon's whisper to its source. In physics, the laws are mostly symmetrical, reversible. If you filmed the collision of two particles then played it backwards, it would still make sense. The math would still work, the rules would still apply. But light, in reality, only ever moves one way in time, even though the equations could allow otherwise. So what breaks the symmetry? What tips the balance? Entropy, that soft, inevitable drift toward disorder. When a photon is emitted, it adds to the spread of energy. When it's absorbed, it leaves behind heat, vibration, uncertainty. And always, the total disorder increases. This is not chaos. This is direction. Entropy doesn't just rise, it defines the future. And the photon is caught in that rise, not as a victim, as a messenger. It tells us by its very path which way time is moving, because it moves only in the direction that increases entropy, never in reverse. This is why we see light from the past but never from the future, not because the future is closed, but because entropy hasn't led us there yet. Now picture this: a single photon, born in the core of a star, escapes through fire and field, passes through space and strikes your eye. Its arrival triggers a tiny change, a signal sent to your brain, a pattern interpreted, a memory formed, disorder increased, the world reshaped, infinitesimally. This is the arrow of time. Light moves forward, not by choice, but by necessity. To move backward would require a reversal of entropy, a decrease in disorder, and that is something the universe simply does not permit on large scales. So the photon becomes more than a traveller. It becomes a compass. Its direction defines our own. You may try to imagine a universe where light moves backward, but in doing so, you'd also have to unburn every flame, unspill every tear, unring every bell. You'd have to undo the dance of atoms, the flicker of stars, the thoughts in your mind, and the universe would resist. Because while the equations allow many things, reality allows only one direction: forward, always forward. And so, light becomes the needle of time. Each photon, a tick, each beam, a breath, each sunrise, the next note in a melody that never plays in reverse. You sit in stillness now, a photon resting in your retina, having given up its journey. It travelled across billions of years, and now it is gone. But its message remains, not just in the image it formed, but in the reminder it carried. Time flows forward, light follows it, and we, slow creatures in a vast and waking universe, use that light to see where we've come from and to feel the soft pull of where we're going. Now picture a beam of light, stretched, not broken, not dimmed, just softened, like taffy drawn thin between fingers. A faint red glow where once there was white, a cosmic exhale. This is redshift. Not just a colour change, but a story. When light leaves a galaxy, it begins its journey at one frequency, a pattern, a tone, a signature. But as it travels, the universe expands beneath it. Space itself stretches, and with it, the wave of the photon. The wavelength grows, its energy lessens, and when it reaches us, perhaps billions of years later, it arrives more gentle, more red, more tired. But is light really tired? Can it age? Can it weaken? Not exactly. Photons do not grow old in the way you do. They do not carry wrinkles or wear. They experience no time, no waiting. But from our perspective, the world of clocks and cores and stars that drift apart, they seem to stretch with the universe itself, and that stretch reveals everything. It's how we know the cosmos is growing. It's how we measure speed and distance across vast gulfs. It's how we look back in time, not with machines, but with light. The more redshifted a photon is, the longer its journey. The more stretched, the older its story. Now imagine the opposite. A beam compressed, tightened, shifted toward blue. This is blue shift, the signature of something rushing toward us. As it does, its waves are compressed by motion. Its energy increases, not because it wants to hurt, but because motion has rules. The Doppler effect, you might recall it. The way a siren seems higher pitched as it approaches, lower as it leaves. Light follows the same rhythm, but with far more consequence. Because in the language of redshift and blue shift, we hear the motion of the universe itself. We see galaxies fleeing. We find stars pulled into black holes. We feel the presence of motion we cannot see. Dark matter, hidden orbits, gravitational wells, all from light that does not change speed, but changes form. So we ask again, is this a kind of exhaustion? Do photons get tired? Number. They are not runners losing steam. They are dancers following a floor that moves beneath them. It is space that stretches, and light, constant as ever, is stretched with it. What you see as tiredness is the universe unfolding. What you see as a softening is distance made visible. And so every photon you receive tells two things: where it came from and how far it had to travel, not in kilometers, but in red. And now, lean in. Because some light is stretched so far it leaves the visible spectrum behind. Beyond red, beyond infrared, it becomes microwave. It becomes the faint background hum that fills all of space, the leftover light from when the universe was young and hot and filled with fire, the cosmic microwave background. It's not a star, it's not a beam, it's a blanket, a field of photons released just after the universe became transparent, drifting outward ever since, stretched, cooled, softened by expansion until they barely whisper. And yet they are everywhere, passing through you now, billions of them, relics of a time when light first moved freely, and they too obey the speed limit. They too arrive unchanged in pace, even if their energy has softened, even if their message is ancient. You might ask, if a photon has lost energy, where did it go? And the answer, gentle and subtle, is, it didn't go anywhere. The energy isn't lost, it is transformed. Redshift doesn't erase, it reveals. And that is perhaps the final lesson of this part of the journey. Light does not decay. It transforms. It sings in new keys. It speaks with softer tones. And we, the listeners, learn to read its shift like a bedtime story. With every longer wavelength a chapter. With every dimmer beam a deeper past. With every red-shifted spark a lullaby from the beginning of time. The edges have begun to blur, not because you're tired, though you may be, but because we are nearing the deepest boundary of what light can reveal. Not the farthest distance, the final distance, the place where even photons, ever faithful, cannot escape. This is the event horizon, the line drawn by a black hole, the place where space curves so steeply, so absolutely, that the path forward leads only inward, not metaphorically, not poetically, mathematically. The escape velocity at that horizon equals the speed of light, and so, nothing with mass can flee, not rockets, not thoughts, not even photons. Because to escape, you'd need to move faster than the limit, and the limit, as we've learned, never yields. Here, light meets its boundary. It does not bounce, it does not pause, it crosses, and then it never returns. Let's slow time even more now. You're floating above the horizon, far enough to be safe, but close enough to feel the curve of space beneath you. Imagine a photon emitted by your hand aimed upward, toward the sky, toward freedom. It escapes. Now imagine another, emitted just below you. It tries, but the space is bent so deeply that the photon climbs more slowly, more weakly, more redshifted, until it fails to reach you. Instead, it falls back. Not because it lost will, but because the curve became a wall. Even light, which bends but does not break, is folded inward by gravity this strong. Now picture one final photon, emitted from the very edge of the event horizon. It rises, infinitely slowly, its wavelength stretches, endlessly, its color redshifts, beyond sight. From your perspective, it never truly escapes. Its journey upward is frozen in time, the last visible flicker from an object falling in. This is gravitational redshift at its extreme, and it tells us something profound. The closer light is born to an event horizon, the harder it becomes to see. It stretches, fades, and eventually disappears, not because it stopped existing, but because time itself slowed to stillness. You see, from far away, an object falling into a black hole never quite crosses the event horizon. It slows, it dims, it halts. But from its own perspective, in its own local time, the fall continues. It crosses the threshold. Time does not stop for it, only for us. This dual perspective, both true, both contradictory, is the final gift of the speed of light. It forces us to accept that different observers live in different versions of time. What is frozen to one is flowing to another. What is unreachable to one is already gone to the other, and all of it is governed by the same rhythm, light's constant speed. This boundary, the event horizon, is not a wall, but a silence, a place where communication ends, where light can no longer carry messages outward, where causality breaks not because rules are broken, but because no signals can be sent. The black hole becomes a region without return, and yet it is not empty. It hums, it rotates, it whispers through gravity. And perhaps, as some theories suggest, it evaporates, slowly releasing energy through quantum processes, one photon at a time, until it fades away. Even then, those escaping photons, that last breath of a vanishing black hole, obey the same law. They do not exceed the limit. They stretch as they rise. They bend as they fly. They tell the story, not just of the black hole, but of the limit itself. Because if anything could break free faster than light, it would be here. And yet nothing does. Even in the place where time nearly stops, the law still holds. The constant remains. So now we rest. We've walked beside light from its softest ripples in the quantum foam, through its journey across galaxies to its vanishing at the brink of no return. We've listened to what photons whisper, and now, at the end, we do not chase light anymore. We let it go, not because it's beyond us, but because it has shown us all it could. The lab is quiet now. Every lens has cooled. Every beam has faded. The stars overhead have blurred into a velvet haze, and the world has slowed just enough. You're resting, not quite asleep, but softer than waking, and beside you, in the dark, the quiet pulse of understanding hums, steady as breath. Light, so swift, so constant, was never in a hurry. It showed you the limits not as barriers, but as rhythms. It walked with you across time and space, not as a guide, but as a thread, always patient, always in motion. Now the universe folds gently around you, not as math, not as distance, but as comfort. The photons have done their work. They've told their stories. They've stretched across the ages just to reach your eyes, your skin, your mind. And now they rest. Not in stillness, they cannot stop, but in silence. In the warmth they've left behind, in the knowing they've delivered. You lie still as galaxies drift outward, quietly pulling the sky with them. You do not need to follow. There's nothing more to chase. Because the question was never, why can't anything go faster? It was what would be lost if it could. And now you know. In light steadiness, reality has order. In its limit, time has direction. In its silence, the universe makes sense. So breathe. Let the pulse of photons slip away into the fabric of sleep. Let each redshifted echo carry your thoughts outward. Not far, not fast, just enough. There is no need to move. The journey is complete, and the rhythm that holds the stars will hold you too.